Good day everyone, I'm Sanggunan from Human Computer Interaction Lab at KAIST and Chatham Labs. We conducted this work as the summer internship program of Chatham Labs, and I appreciate to all colleagues involved in this project. In this work, we present practical design guidelines for designing gauge-based marking menu, and also present scale-invariant gauge marking menu interface, named StickyPie. GUI menu interfaces offer help to novice users because they enable users to input a command or select an item by navigating through the GUI interface, and don't require the users to have prior knowledge about the structure of the menu. However, for expert users, navigating these GUIs can be cumbersome and slow. Thus, many applications also provide hotkey functionality to offer expert users greater input efficiency. Marking menu technique presented to use advantage of both GUI menu for novice users and hotkey input for expert users. It also offers facilitate gradual transitions towards expert user. Our aim on this work is optimizing the marking menu interface for eye gauge input modality. There is an early adaptation of gauge-based marking menu named PI technique. The same with early marking menu design, PI technique uses hierarchical pie menu. To select an item on PI menu, a user could move their eyes from the inner circle of the pie to a point outside the border. When a user moves their eyes out to the border, the crossed wedge is selected. Then the next pie appears at the center position of the crossed wedge. We first tested traditional pie menu interface with various sizes and layouts. We then found that the overshoot error was the highest proportion among the various types of errors. Overshoot error refers to unintended selections caused when a user's eye crosses the border of the next pie unintentionally. It is caused by the scale variance feature of the regular pie menu. Therefore, we designed the scale invariant gauge marking menu named StickyPie. With regular pie, a selection is done once the eye cursor is crossing the border. Otherwise, with StickyPie, a selection is done once the saccadic eye movement is done after the eye cursor is crossing the border. Therefore, regular pie could invoke multiple border crossing actions if the saccade distance is too long to over the multiple borders. Otherwise, StickyPie could invoke only one border crossing action per single saccade stroke, because the next pie landed at the saccade landing position regardless of the distance of the saccade eye movement. This is the demonstration video of the StickyPie. The moving trail on the video is showing a user's eye movement. We expected that the scale invariant nature of StickyPie has the advantage of less overshoot errors and better support of the transition from novice user to expert user. To demonstrate those advantages, we compared StickyPie versus regular pie. Building knowledge expertise of the menu structure is important to support of the transition from novice user to expert user. So, we designed a practical marking menu using 32 command sets for universal VR applications. To design the menu, we follow our design guidelines derived from previous experiments in this paper. This experiment, conducted with 8 participants, and each participant performed a total of 288 tasks per each technique over 3 days. As a result, in terms of information transfer rate, StickyPie shows significantly better input efficiency than regular pie. In terms of the number of overshoot errors, StickyPie generated the errors 73% less than that of regular pie. We then surveyed perceived expertise. It is based on how many commands can be executed by gesture input rather navigating the GUI menu. At the first day, we found the participants felt more confident to use gesture input with StickyPie. Finally, we surveyed which one is better to use. 6 of 8 participants preferred the StickyPie because it is less concerned about the position of the eye cursor after a border crossing. And it is easier to input gestures using StickyPie, and that they were more confident than with regular pie. One participant preferred regular pie because he sometimes felt increasing eye fatigue when a pie of StickyPie appeared in the peripheral region. Our contribution of this paper is threefold. First, we present design guideline for the gauge marking menu for AR/VR. Second, from the design guideline, we present practical example of designing the gauge marking menu for general VR application. This example could help how our design guideline apply for designing practical gauge marking menu. Lastly, we present StickyPie and demonstrate better usability over regular pie.